and recorded and fixed in a timely manner is there. So this is one of a very important criteria why we chose OpenEMR as our project. Now, looking back a bit on some of the past security research done by other teams, Project Insecurity, they had done a particular audit on a pen test on this OpenEMR version 5. And they have uncovered a number of SQL injections, RCEs, in 2018 when it was publicized. This proves that there are people out there looking at this application, but at the same time, it also means that it's going to be a bit challenging for us if the code base did not change much since 2018. We did this in 2021. It will be likely that we might not find the same vulnerabilities. Now, on SonarBlock website, it was publicized that a couple of command injection, XSS, insecure API permission, and SQL injections were reported. And it hit the news, and it was widely known that the OpenEMR project was vulnerable to such vulnerabilities. Now, I'll move on to the technical findings. This is an overview of how we perform the testing. It's nothing sophisticated. There's nothing very difficult about it. It was a combination of manual source code analysis and black box testing, the kind of stuff that we do perform every day, in fact. What we found were insufficient authorization checks and also input validation, insufficient input validation leading to XSS. Now, we reported the bugs directly to the OpenEMR project team. They replied to us in a fairly fast, promptly manner. And after we have even submitted the POC, we waited on them to fix the vulnerability. And after which we triaged it into Mitre and got the CVEs published. Now, this is a summary finding of the application that we researched. It was OpenEMR version 6.0. The version release was 2021. The researchers' names are listed here, and the type of bugs classification is IDOR and XSS. In total, we found 8 vulnerabilities. However, one of the vulnerabilities led to 61 IDORs. Obviously, we weren't chasing CVEs. We don't want 61 CVEs. We just registered 8 separate CVEs just to classify the bugs. Now, the top 2 vulnerabilities were rated as high, CVSS 8.1 and 8.3, where non-privileged users were able to read or disclose patient records, and followed by a couple of cross-site scripting and unauthenticated, well, not unauthenticated, non-privileged download of patient records, and a couple of stored cross-site scripting, which my colleagues behind here will walk you through some of it. Now, the first vulnerability on top was rated as high, CVE 2022-1459. What happened was a non-privileged user, such as an accountant or a front office personnel, is able to view patient records on the system. Now, the problem here is due to insufficient access control list on the endpoint. The affected URL is mentioned in the box at the bottom. You can see that the URL has edit lit equals 3. That is the parameter that was vulnerable that we found. It requires authentication, so therefore you will require at least a low privilege user. In essence, the application or the patient records should only be accessible by the admin or the medical personnel. But in this case, a low privilege account was able to download patient records. And in the following slides, I will show you how we discovered the vulnerability. Over here is a snapshot of the UI. And you can see on the top right-hand corner there is the administrator user. He's the person that currently logged into the system, and he can view the dashboard. Now, the dashboard contains the patient medical records. This is considered the correct behavior of the application. Now, what happened is when we download, when we log in as an accountant user, by right, the accountant user should only be able to view non-medical records such as billing information. However, what we found by tampering the parameter that I showed you in the previous slide, we were able to view patient medical records. So therefore, this shows that there's a failure in the authorization check in that particular web page, or the endpoint in particular. Now this is the GET request. So they use just a simple GET request like I showed in the previous slide. Just by doing a GET request to the record disclosure.php with the edit lit equals to 3, that is the temporal parameter. At the bottom here, you see the cookie. Now this is the accounting user cookie, the non-privileged user. So what we did was we swapped it. Instead of having the admin cookie, we swapped it with the accounting user cookie. And just by using the accountant user cookie, we are able to fetch the patient record. And the parameter edit lit equals to 3, you can just increment that number, 3, 4, 5, 6, and so forth, and you'll be able to view other patient records. So it's as simple as opening the browser, pointing the browser to that particular endpoint, and just modify that last parameter at the back there, the number, and just keep incrementing it, and you will be able to download patient records. Now, we were wondering why this behavior was prevalent. In fact, there are about 62 web pages or endpoints that had similar issue. Now, I took a look at the source code. For example, the record underscore disclosure.php web page, at the top, as you can see from line number 12 all the way to line number 25, there isn't any ACL checks. This was found on version 6.0, the particular application that we were doing our research. Now, after we have reported the issue and such, they fixed the problem on the following version, 6.1.0. I download the source code again on the same particular web page just to find out what did they do. And what I found was, on line number 23 to 27, they added the ACL check. In fact, on line number 30 to 34, they added another check where if the authorization check failed, the page will just exit. So this was the missing piece of the code in the system that was not there, was absent in version 6.0. So only then we found out, that's why the problem was prevalent on 61 other pages or endpoints on this particular application. So we registered this as a CVE by itself. However, the following sweep of the entire application was done by my colleague. So he thoroughly went through practically all the endpoints belonging to OpenEMR, and he found a total of 62 other issues, similar issues, which I will pass the mic to him now to tell you, maybe he can tell you how he discovered and how he did it.
Okay, testing, okay, thank you, Rizan. So I was going to talk about the second CVE, 2022-2493. So this is a missing function level access control issue. In the OpenEMR, right, there are total 5 user role types. So there are a super admin, and the accounting, front office, and vigilation and clinician. So the super admin is the highest privilege in this application. So it can access all the modules within the application. And another user role type, they are considered as a standard user, and they have their own permission and modules. Based on my findings, any user in this application can access to some of the admin modules. And other than that, the user like accounting and front office and vigilation, they have a promiscuous privilege issue, meaning that, for example, accounting user is supposed to be view the billing and the payment data, But in this case, the front office and visitation and coordination is able to view the billing and the payment data also. So this proves that they're having a access control issue. Usually this kind of a vulnerability can be picked up by the automated tool, and it requires manual testing to identify it. In total, we have discovered 62 vulnerable instances, and we have consolidated them into one CVE because they are in the same category, and I don't think the owner will issue a 62 CV for us. And I will talk about the recommendation for this one is they are heavy relying on the UI to implement the access control. This is not a good practice, so they require a server-side validation to check the access control. So this is a list of the vulnerable instance, but I only show part of it here because it's too many already. So red color means that this is unauthorized access to those endpoints and modules. Green meaning that that user role is authorized to access to the modules. So one thing to highlighting here is the list of endpoint is belonging to the admin, which all the any user can be accessible. And some of it is very critical. I will show it in the next few slides. And another thing here is coordination, the front office and the front office and the visitation and the coordination can access the billing and the payment info, which is not supposed to. Those are the modules can be accessible by the accounting. Okay, this is the first POC I'm going to show. So, like what I said, any user, right, can access to admin modules. So this is, in order to exploit this kind of vulnerability, right, first we need to identify the endpoints. So here is the admin dashboard. As we can see, there is a admin header section which to navigate to the admin modules. So for this one, I choose to navigate to form administration. So when we navigate to that modules, right, the URL here is always remaining the same. So it will be the same if I navigate to another module as well. So the path will be the same on the URL with stretch main.php. So there is some process on the background which we cannot see by our naked eyes. So in order for us to discover the real endpoints, one tool we can use on the built-in browser is an inspect element. And as we can see here at the bottom, we can, when we browse to the modules, if we're using the inspect element with the network, we can view the network, the traffic sending to which endpoint. So this is how we can capture the endpoint, but this may not very user-friendly. So the second approach we can use is we can use a tool, it's called burst suite. I believe this is an essential tool for the security testing. I believe most of you may see and use it before. And how the burst suite do is it will capture all the HTTP requests before sending to the server. And then, as we can see on the screenshot, those are the endpoint I captured. The key finding here is the one I highlighted, which is the phone admin.php. Now we managed to capture the vulnerable endpoint. So the next thing we need to do is we can log in as any user on the application. So what I choose is a front office because this user is considered as a lowest priority user on this application. So this is the dashboard of the front office looks like. As we can see, there is no administration session header here. This proves that this user is not allowed to access to that modules. So we just need to, we have captured the vulnerable endpoint just now. What we need to do is we just need to copy paste and then we can browse it directly on the phone, on the browser. Then we can access the modules. This is the admin modules which is accessed by the front office. And in these modules, right, it allows a user to modify the access control for phones within the application, meaning that this will allow an attacker to modify the access control to gain more access to another modules, which will compromise mostly the 70% of the application. And this is the second POC. It's quite similar like the first one, but this one is billing and the payment modules. And this modules is also cannot be viewed by the front office, but in this case, the front office is managed to browse the, we managed to capture the endpoint and browse it on the on this user session, and we can see that we can see the billing manager on the bottom. We can see there is a patient payment record. If we click further on the patient record, actually we can issue the billing without paying any fee. So we can get a free medical consulting on this. So this is the two POC I'm going to present because there are too many due to the timing. I only selected two POC that I think is the most impactful. And that's it for my this CVE. I will pass it for Ali to continue his finding.
All right, thank you, Aden. Morning, everyone. So I will present one findings that I found, which non-privileged user can actually create a new rule and lead to stored cross-site scripting. So this non-privileged user, which include accountant or front office, they can actually create a new rule by injecting arbitrary web script and lead to stored cross-site scripting in one endpoint, which is interface superrules index.php in the edit submit summary in one of the vulnerable parameter called FID title. So this SSS payload will be triggered in the plain rules, which can only be viewed by privileged user, or we can call it as admin roles. So our recommendation is quite simple, which is to ensure that all inputs from the user are sanitized before it being reflected or processed by the server itself. So overall, we found 4 stored cross-site scripting and 1 reflected SSS. And yes, you need to authenticate it to reproduce all of the issues that I will share in the next slide. So before I jump into all the issue reproduction of the CVEs, I'm going to share what is actually you can see inside this Open EMR CMS. So in this application, there are a lot of inputs, forms, modules, and also subcategory. For me, as a new beginner in vulnerability research, I might feel overwhelmed. So there are a few methodology and techniques that I would like to try. And I found that this one simple technique is quite simple, but it's helped me to find several CVEs in this application. So I'm going to explain it on this page. So if you look into this image, you can see that there are a lot of inputs forms in here. So what I did is very simple. You just utilize Ctrl+C to copy and Ctrl+V to paste a simple payload as alert. But the difference is you just put a unique numbers on all the inputs. So for example, if you found these input forms, you set a range, for example, 1 until 9 are used in this one endpoint, and I just take note of this endpoint. So when we try to browse into different pages and we found another input forms, you set another range, a unique one, and you just take note of that endpoints. So keep browsing until you find the end of the input form that you can find in this application. And with these simple techniques, you can actually see that when we try to browse into different pages, might be hidden one, you might see this pop up everywhere with different numbers. So the reason behind this simple technique is to ensure that I could follow where is the payload coming from, and it helped us to help the vendor itself to identify where is the payload coming from. And that's how we could actually get these CVEs. So what I could say is that a simple technique but very efficient on this application. So now I'm going to explain the issue reproduction of the CVE 2022-1179. If you look into this image, we are now as administrator. So as administrator, you can see the rules subcategory, but not in the case of accountant user. You cannot see the GUI access to the rules subcategory. So what I did is very simple. You just intercept the request for an administrator trying to create a new rules, And by changing the cookie to a counter user or non-privileged user, we can, and I also identified that the parameter FID title is vulnerable to SSS. So in this POC, I use fetch, where we pass the document.cookie in the server, attacker server in here, and we pass it in the URL parameter of C. So by sending this request, this non-privileged user could actually store this payload in the page rules. So when administrator trying to view or browse to the page rules in their admin page, eventually it will send and trigger the SSS payload to the attacker server. And for example, in here, I use Bird Collaborator. And if you look into here, this is the document.cookie which is passed to the attacker server. And with this cookie, the attacker can easily update it in their browser, or if they know the endpoints that they want to use or utilize, they just need to update the cookies to the admin cookies that he got. And if you look into here, we are now a counting user, but actually when we try to browse into different endpoints, we are actually browse it as administrator. So that is the kind of impact where from SSS we could actually get the admin cookies and view any endpoints as administrator. And that's all from me. I will pass back to Rizan for the next slide. Thank you.
All right, so this is the disclosure timeline. In September 2021, we initiated the report. We sent it to the Open EMR team. Within a few days, we received a confirmation from them. And it took them quite some time until April 24, 2022 to release the final patch. The patches were released in batches. The final patch was done in 24th April, version 6.1. And that's only after that, that's when we triaged the CVEs with Maitre. What I want to point out is the learnings. Now, we are basically pen testers day in, day out. Now, a lot of times there are very trivial matters that we report. However, for this particular research, we focus solely on the business impact. So we forget about missing security headers, weak ciphers, the boring stuff, but give them the stuff that we feel that needs to be fixed. We also use the source code for analysis. Being open source, we had the luxury of downloading the source, analyzing it manually, and also using some automated tools, gave us the confidence that we were able to produce some results. The third point is very, very important. Choose your VDP targets or program wisely. There were times where we worked on other programs. We found really critical bugs for some very large organizations, which we can't even disclose. They fixed it, but we can't disclose. So that's pretty much a bit puts us in a difficult position also. But anyway, so choosing the right programs that have full disclosure is...
As tradition, sorry, we have to pause your presentation. You have to share that with your teammates. So you have to share that. Ida? Oh, okay.
Ali and me can't drink because we will just...
Right. Thank you, thank you. You need water? Aden.
Yeah, we are allergic to alcohol. All right, so I mentioned about choosing the VDP very wisely. Choose programs that have full disclosure and study the program before delving into a VR project with them. Now, look for appropriate channels for triage. I mentioned that we tried to, we tried to contact Maitre. They were fantastic. Unfortunately, it was a bit slow. We found another platform, hunter.dev. This platform will triage CVEs for any project on GitHub. So they were really fantastic. They helped us to get the CVs published in a timely manner. And I feel that VDPs are a great way for beginners to get into VR, especially if you're just starting out, you don't know much about security research. Use your strong points. Like for us, we do a lot of web pen testing, so that's why we chose web as our VR. And most importantly, work as a team with the combination of 3 of us between 6 to 8 weeks last year. We managed to produce over 70 vulnerabilities in a single program. And remember to share whatever that you have learned with the community. Everything goes around. We learn from each other. There's nothing to hide. All right. Thank you, everyone. Any questions?
All right, thank you very much. Are there any questions from the audience? Nothing? You will share your contact details, probably? Yeah. All right, thank you very much, Aden and the BAE gangs. Thank you, guys.